Hello students, welcome back to Memoneet. I am Prajita, your chemistry SME, and I am here with you all. So I hope all of you are doing good. So students, welcome back to another session. So this is your second session on the chapter solutions. So let me again tell you that this chapter solutions is from class 12th and it is going to come in your Bhramastra part test 2. Okay, so if you have seen the syllabus of Bhramastra part test 2, so in chemistry we have given you the chapter solution because the reason is it's a very basic chapter first of all, and apart from being a very basic chapter, it is an important one also. Like a lot of questions are being asked from this chapter in your Neet examination. So we are going to take it as of now. Okay, so first of all, in the last session, we talked about what are the different types of solutions that we are having, what are the different ways of representing the concentration of solution. That is very important, like in the form of mole fraction, concentrations are there, molality, mass percentage, volume percentage, all of that. Then we saw about the different types of solutions, like liquid solutions. We discussed about the vapor pressure. We studied what is solubility and what are the factors that affect the solubility. Okay, so these are the topics we have covered in the last session. Those who have not watched the last session, please go and watch that first and then come back to this session. Then you will be able to understand it in a better way. Alright, and now what I want you people to do is, I hope all of you have watched that lecture. So before watching this lecture or after watching this lecture, I want you to go to your NCERT book. Okay, take your NCERT book. There you have in-text questions, right? In-text questions. So I want you people to solve the in-text questions from 2.1 to 2.7. Okay, means 7 questions you have to solve. And let me tell you, these all 7 questions are your numericals. Okay, now let me tell you the reason why I am telling you to solve these questions, because the questions that are coming in your Neet examination from this particular chapter, they are mainly numerical problems. Okay, so I want you to solve these in-text questions so that you can get an idea of how we are going to solve these numerical problems. Okay, so please go and solve that, and no worries, if you are having any doubt in any of the question, just comment below that ma'am, I am having doubt in question number 2.1 or 2.2, or I am not able to understand it. So I will create a special video for all of you where I will be discussing the numerical problems. Okay, no issues. We are here to help you all. So what you can do is please solve the questions. But before that, I want you people to solve these questions on your own. If you are not able to do it and any doubt comes across, so please comment there in the description, like here, comment. So, okay, ma'am, I am having this issue in this much question, so I will be explaining you all. Okay, because numerical problems are important for this particular chapter. And as I always say, the more you practice, more clear your concepts would be. So have you heard that saying that practice makes a man perfect? Okay, or practice makes a person perfect. Now you will say, ma'am, why it's always man who? So let's write practice makes a person perfect. So that's what I want you to be, perfect, okay, in every aspect. So for that, what you have to do is go and practice these questions from this chapter. All right, then we will start with the next topics. Okay, so practice and practice more. All right, okay. So the topics for today, as you can see, we are going to study about ideal and non-ideal solutions, and we will be starting colligative properties. So there are 4 colligative properties. Okay, 2 I will be covering in this lecture and 2 I will be covering in the other lecture. Okay, is that fine? So that there is no burden on us that we have to study all of the things at once. We will go slow and steadily. Okay, now again one quotation comes to my mind, slow and steady wins the race. Okay, we don't have to rush up, we don't have to put everything in our heads at once. No, we are going to do it slow and steadily, and definitely we are going to win the race. Okay, all right then. So let's start with by talking about the ideal and non-ideal solutions. Okay, so class, before I talk about ideal and non-ideal solutions, I want you to know about the Rawls law. So Rawls law we have discussed in the last class, right? I hope most of you remember, but still if you people don't remember, let me recall that for you. Now what is Raoult's law? Raoult's law states its active solution. Okay, so for a liquid solution in which we are having a volatile liquids, means both the liquids are volatile. So it states that for a solution of volatile liquids, the partial pressure of each of the component is directly proportional to the mole fraction. Okay, so if there is any component, the partial pressure of that component will be proportional to the mole fraction. And when we remove this proportionality sign, this constant comes as, this is the vapor pressure in pure state. So from that we can say that the vapor pressure is directly proportional to the mole fraction, and this is the straight line graph we are going to get. Okay, so this is our Raoult's law that we have studied in the last class, that for a solution of volatile liquids, the partial vapor pressure is directly proportional to the mole fraction. Alright, so that is going to be the Raoult's law. Now, if I talk about ideal and non-ideal solutions, so we are basically talking about liquid-liquid solutions, okay? Liquid-liquid solutions. So in that case, the first one is an ideal solution. Now, what is an ideal solution? Let me tell you. See, we will do it slowly. We must understand every point. So ideal solutions are the ones which obey Raoult's law. Just a minute. Which obeys Raoult's law at all compositions of solute in solvent at all temperature. That means that these are the ones which obey Raoult's law over entire range of concentration. Okay, means ऐसा नहीं होगा कि एक ही concentration पर आपका Raoult's law obey होगा. Entire range, any kind of concentration of your solute in solvent is there, it is going to obey the Raoult's law. That is known as the ideal solution. Okay, fine. So now what are these ideal solutions? So let's say I am having two liquids A and B, and I am mixing them to form a solution AB. Alright, so what is A and B? Now A will have these intermolecular attractions, like there will be some forces of attraction. Let's say कि those forces of attraction are AA. कि AA क्या है? Force of attraction in your like component A. Similarly, BB will be the force intermolecular attractions between the component B. But when they combine with each other, like when we are mixing them to form a solutions, then there will be some interactions between A and B as well. AA and BB will be there. Okay, AA and BB interactions will be there, no doubt, because it's not chemically breaking down, fine. It's a mixture, it's a solution. But apart from that, there will be AB interactions also. कि A and B आपस में भी तो interact करेंगे ना, they will be interacting with each other as well. So AB interactions would also be there. Okay, now ideal solutions कब बनते हैं? Like when do we get these ideal solutions? We get these ideal solutions when the AA and BB molecular interactions will be same as that of AB molecular interactions. Okay, means nearly same. AA and BB interactions जो हैं, they will be nearly same as AB interactions. In that case, we will be getting ideal solutions. Okay, so that is the main thing you must know about an ideal solution first. Now the second point is, you have to remember two things. Okay, that is the delta H mixing is 0 and delta V mixing is 0. Now what is this delta H mixing and delta V mixing? So this two terms are 0. Very important. This can be asked in your exam also. Now class, what that means whenever we are mixing the two components, so no heat will be evolved or absorbed. Okay, so means if there is no heat evolved or absorbed, then there will be no change in the enthalpy, means the energy change would be 0. That is why we are saying delta H is 0. Delta represents the change. Okay, change. Then delta V mixing is also 0. Now that means that when we are mixing, okay, the two components, so the volume of the solution would be equal to the sum of volume of the components. Alright, means it will neither contract nor expand. That's the meaning. So means it will be equal to the sum of volume of the two components. Means there would not be any volume change. See, I am saying that delta represents change. So there would not be any volume change. So it would be equal to 0. So that is the main 2 points that you have to remember, that delta H and delta V mixing are 0. Now you know no solution is ideal, okay, but yeah, it can show a nearly ideal behavior, okay. For example, the mixture of N-hexane and N-heptane is there, mixture of CCl4 and SiCl4 is there, then mixture of bromoethane and chloroethane is there. So these are nearly showing the ideal behavior. So all the points I have mentioned to you regarding the ideal solutions, please note down all the points in detail, okay. First thing, you must know about the like it obeys Raoult's law, then delta H mixing, delta V mixing, then about the interactions, intermolecular attractive forces, okay. Now then, what is non-ideal solution? Now you might have got an idea, students, कि non-ideal solution will be the one which does not obey Raoult's law over entire range of composition, okay. They are not going to obey the Raoult's law over entire range of composition, okay. So just now we have discussed what is Raoult's law, कि the vapor pressure or the partial pressure of each component is directly proportional to the mole fraction, alright. So in this case, what will happen? The vapor pressure would be more or less than what is predicted by the Raoult's law equation. कि उतना नहीं होगा, the vapor pressure will not be exactly that is predicted by Raoult's law, but it would be more or less than that, कि ज्यादा या कम हो सकता है. अब दो cases बनते हैं यहाँ पर, okay. तो in this case, you know कि delta H mixing and delta V mixing जो है, that will not be equal to 0. Means there would be energy change and there would be volume change as well, okay. Now, two cases. So if the vapor pressure is more, the first case is if the vapor pressure is more than what is predicted by the Raoult's law. So in that case, we say कि the solution shows positive deviation from the Raoult's law. Okay, let's first discuss about positive deviation in detail, then we will discuss negative. So positive deviation is, again, I will like to tell you कि if we have discussed the type of interaction, so positive deviation कब होती है? When the AB interactions are weaker than the AA or BB interactions, okay? जब AB interactions weaker होंगी. Alright, now AB interactions weaker means जो intermolecular forces of attraction है between the solute and the solvent would be less than solute forces or solvent forces. So if the AB interactions are weaker, okay, the intermolecular forces of attraction are weaker, so it means that it will be easier for the vapors to escape. राइट if अगर वो फोर्स ऑफ अट्रैक्शन अगर किसी चीज ने उसको कम रोक के रखा है, फोर्स इज लेस, सो इट विल बी इजियर फॉर इट टू एस्केप, नो, वो जल्दी से एस्केप हो जाएगा. सो देयर विल बी द मोर टेंडेंसी टू एस्केप, इन दैट केस वेपर प्रेशर इज इंक्रीजिंग, दैट्स व्हाट वी आर सेइंग कि वेपर प्रेशर ज्यादा हो जाएगा, इट इज गोइंग टू इंक्रीज इन द केस ऑफ सॉल्यूशन, ओके, बिकॉज द AB इंट्रैक्शंस आर वीकर. सो ये भी आपको पता होना चाहिए कि व्हाई द वेपर प्रेशर वुड बी मोर. ऑलराइट, so that is the case. So in that case, delta H mixing would be greater than 0 and delta V mixing would also be greater than 0. Alright. So this is the graph for the positive deviation. Can you see? There is this positive deviation like this. From the dotted line, we can see the positive deviation. Now, what is the example? Example is cyclohexane and ethanol. You can write ethanol and acetone. So ethanol में there is hydrogen bonding, okay. So the interactions are very strong. Let's say AA interactions are very strong. But when you add acetone to it, so acetone molecules will get in between the ethanol molecules. They will break those hydrogen bonds. So जो AB interactions होंगी, they will become weaker, okay, than the AA or BB interactions. So that is why ethanol and acetone will also show positive deviation from the Raoult's law, okay. Now, if the vapor pressure is less, I told you now two cases. So, if the vapor pressure is less than what is predicted by your Raoult's law, then it shows negative deviation from the ideal behavior. Okay. Now, in this case, what will happen? The AA or the BB interactions would be weaker than the solute-solvent interactions. Means, when you are mixing those two components, a resulting mixture is formed which is having stronger force of attraction than were there in the original components. Okay, force of attraction वहां पर ज्यादा हो जाएंगे. So in this case,
so there will be a decrease in vapor pressure. Okay, decrease in vapor pressure because of the obvious reasons, because when AB interactions are stronger, okay, when we are mixing those two components and the resulting mixture is having stronger interactions, so it would be difficult for the vapors to escape, no? So it will actually decrease the escaping tendency of the vapors. Let me give you a very good example. So the example is of chloroform and acetone. Okay, so in chloroform and acetone there are some intermolecular attractions, but when they combine, when we are mixing them, so there is a formation of hydrogen bonding. So this is your acetone, okay, and this is your chloroform. So there exists the hydrogen bonding between the oxygen and the hydrogen here. So because of this hydrogen bond, you know hydrogen bond is a strong bond. So what will happen in this case? The AB interactions would be stronger and the vapors will find it difficult to escape. So there will be a lowering in the vapor pressure, means the vapor pressure would be less and the system will show, or your solution will show, negative deviation from the Raoult's law, and this is the kind of graph you are going to get. Okay, so these are the main points you must remember about the positive and the negative deviation. Now there is something that is known as azeotropes, that's also there in your NCERT. You might get one or two theoretical questions from it. Okay, azeotropes may say you get theoretical question, like they'll give you 4 mixtures. It has come in your 2019 exam also, like directly from NCERT they have asked. That's why I again and again tell you ki read NCERT. Apart from attending these lectures, read NCERT also, because sometimes, or like you can say 30 to 40% questions you get directly from the NCERT. 4 mixtures are given. You have to find the maximum or the minimum boiling azeotrope, and that example is given in NCERT only. So if you go through the PYQ book na, you will find it out. We have mentioned there कि the question is directly from NCERT lines or it is conceptual based. So you will get a clarity on that कि how much questions are directly asked from NCERT. Okay, so go through that PYQ book as well. That is very important. All right. So azeotropes are again your binary mixtures. Binary mixtures means having two components. Now these azeotropes will be having same composition in the vapor phase and the liquid phase as well. So same composition in liquid and vapor phase. And why we call them as azeotropes? So they actually boil at constant temperature. So we call them as constant boiling mixtures also. Means when you mix two components, they will be boiling at a constant temperature. Okay, so that is why they cannot be separated by your fractional distillation. Okay, because they will boil at constant temperature, how you can fractional distillate them, right? Now if any substance or if any solution shows positive deviation from the Raoult's law, okay, this one, if it shows positive deviation from the Raoult's law, it forms minimum boiling azeotrope. Minimum boiling azeotrope means when we are mixing those two components, the resulting boiling point will be lower than that of the two. Okay, so here ethanol and water mixture. Ethanol and water mixture, when we distillate them and we get this 95% ethanol na, so means ethanol and water mixture having 95% ethanol is a minimum boiling azeotrope. Okay, so furthermore distillation is not possible in that case, furthermore fractional distillation. All right, and here the boiling point would be less than that of ethanol and water also. Okay, now the one that shows negative deviation from the Raoult's law, it actually forms maximum boiling azeotrope. Okay, maximum boiling azeotrope means the boiling point will be more than that of the two components. Mixture of nitric acid and water is the maximum boiling azeotrope, in which there is 68% nitric acid and 32% water. All right. So these are the points regarding your azeotropes that you have to keep in mind, and ideal and non-ideal solutions. Now we will be talking about the colligative properties. All right. So students, let us first understand what are colligative properties. Okay, so we have studied that whenever a non-volatile solute is added to a volatile solvent, there is a lowering of vapor pressure, right? The vapor pressure lowers down. Then this lowering of vapor pressure, it is helpful for us to discuss various properties of the liquid-liquid solution, which we call as colligative properties. Now, what is the main feature of these colligative properties? That these properties actually, please note it, that they depend on the number of solute particles. Okay, irrespective of the nature of solute, like whatever is the nature of solute, these properties are going to depend on the number of solute particles only. Okay, so you know colligative is derived from a Latin word colligere. So colli is to like co is together and ligere is to bind, so it means to bind together. Okay, so that is the meaning of colligative properties. It depends on number of solute particles. So the very first colligative property we are going to discuss is the relative lowering of vapor pressure. Okay, lowering of vapor pressure we have already discussed, right? Ki whenever a non-volatile solute is added to a volatile solvent, the vapor pressure reduces. So we are going to discuss the relative lowering of vapor pressure. Now see this diagram. This will tell you how the vapor pressure is reduced in this case. So here students, can you see that this is your pure solvent and you can see the vapor pressure in this case, and when we are adding solute particles, so the vapor pressure has been lowered, right? So there is this lower vapor pressure because when we are adding this non-volatile solute, the escaping tendency of the vapors of the solvent, it decreases. All right. Now what is the thing here we are going to do in colligative properties? So there is going to be an expression at the end where you are going to relate the colligative properties with the number of moles of solute, or you can find out the molar mass of the solute. So I am going to derive the derivation for you people. Okay, so we will be discussing all these derivations for these colligative properties. See, derivations are not going to ask in the Neet exam, so they are going to ask you the numericals based on the final results, but it is very important for us to understand the derivation, then only we don't have to just memorize the result. That would be understood, automatically understood to us. Okay, so that is the reason I am doing the derivation with you all right. Now students, see here, if I talk about, you already know that vapor pressure of a solvent in solution is less than that of pure solvent. All right. Now according to Raoult's law, let's say there are two components A and B. Okay, so according to the Raoult's law, the vapor pressure of the solvent in the solution is equal to x1 p1 naught, right? So here p1 naught is the vapor pressure of your pure solvent. Okay, like in this case there is this vapor pressure, and in this case the vapor pressure will be p1. P1 is the vapor pressure of the solvent in solution. Okay, like, or you can say for the solution. So this is in accordance with the Raoult's law. Okay, now what will be the lowering of vapor pressure? So there will be the change, so delta P1. Now lowering of vapor pressure means earlier this was the vapor pressure, now this is there. How much has been lowered? Kitna kam hua hai? That will be P1 naught minus P1, right? So I can say ki I can put this value here. So P1 naught minus P1 naught x1. So here P1 naught 1 minus x1. Now can anyone tell me ki what is 1 minus x1? Yes, 1 minus x1 would be x2. Do you remember students that the sum of mole fractions is going to be 1 always. So this is the thing that we are going to get. Delta P1 is P1 naught into x2. Now what is this x2? Here you can see that this x2 is going to be the mole fraction of solute, right? Can you see, just now I told you that these colligative properties depends on the number of particles of solute. So here only we are getting that this lowering of vapor pressure is dependent on mole fraction of the solute, right? But if there are several non-volatile solute present, यहाँ पर तो एक ही solute था. If there are more than one solute, so it will depend on the sum of mole fractions. Now what will be the relative lowering of vapor pressure? This is the layering of vapor pressure, lowering. So the relative lowering of vapor pressure means this lowering of vapor pressure divided by the original vapor pressure, which is P1 naught. Okay, this was the, so if we are going to relate it to the original one, that is this case. So delta P1 value क्या होगा? P1 naught minus P1 and divided by P1 naught. तो ये किसके इक्वल आया है हमारे पास? That has come equal to the x2, right? So यहाँ से तो अगर हम denominator में ले जाएं, if we take it in the denominator, so that is coming out to be x2. So this is the like expression for relative lowering of vapor pressure, and this is dependent on the mole fraction of solute. Okay. Now if I say if I am having a dilute solution, okay, see, you know students, you can write this x2 in the form of number of moles as well. So that is equal to N2 divided by N1 plus N2. Okay. So if for dilute solution, let's say the number of moles of solute would be very much less than the number of moles of solvent. So यहाँ से we can neglect N1. So N2 in the denominator. So it will be P1 naught minus P1 upon P1 naught is equal to N2 upon N1. Now students, you know that number of moles का formula क्या होता है? The given weight upon or a given mass upon molar mass, right? तो यहाँ पर हम लिख सकते हैं W2 upon M2 for the solute and W1 upon M1 for the solvent. Okay, so here it is going to be W2 into M1 and upon M2 into W1. P1 naught minus P1 upon P1 naught. So from this expression, you can calculate the value of molar mass of the solute. So this is what we are going to derive for every colligative property. Alright, I hope this much is clear. Now students, we will be talking about the second colligative property, which is elevation in boiling point. Now firstly, to understand this, firstly you must understand what does this elevation in boiling point means. Then derivation is very easy, that's not difficult. So students, you might have studied in your class 11th or like you are going to study. So whenever there is a vapor pressure of the liquid now, so vapor pressure of the liquid, it actually increases with temperature. Okay, when we are increasing the temperature of a liquid, more and more particles will go into the vapor phase, so vapor pressure is going to increase and the liquid starts to boil at that temperature at which the vapor pressure becomes equal to the atmospheric pressure. So you know, boiling point of a liquid is that temperature at which the vapor pressure becomes equal to the atmospheric pressure. Okay, for example, if I talk about water, water boils at 100 degrees Celsius, means 273.15 Kelvin, right? So at this temperature, the vapor pressure of water is 1.013 bar, which is your atmospheric pressure, or 1 atmosphere only, right? So that's why it's the boiling point of water. All right, that is the case. So now what will happen? We have just discussed that when we are adding a solute to any solvent, so its vapor pressure decreases, right? Let's say I am adding sucrose to water. So for sucrose solution, what will be the vapor pressure at this temperature? The vapor pressure would be less than 1.013 bar because vapor pressure decreases. Class, ये अभी हमने देखा ना कि vapor pressure decreases, lowering of vapor pressure. So it will be lower than 1.013 bar at 100 degrees Celsius. Okay. Now if I want to boil this sucrose solution, it means I need to increase the vapor pressure. Alright, because boiling point is that temperature जहाँ पर vapor pressure is equal to atmospheric pressure. So I need to increase the vapor pressure to boil it, and to increase the vapor pressure, what I have to do? I have to increase the temperature. Alright, so I have to increase the temperature above 100 degrees Celsius. So means this sucrose solution will boil at a temperature which is above 273.15 Kelvin. So that is why we say कि boiling point of the solution is always more than the boiling point of pure solvent. So this is what we call the elevation in boiling point. Okay. Alright, so now let's say if TB naught is the boiling point of pure solvent, okay, TB naught we are taking, it's the boiling point of pure solvent, whereas TB is the boiling point of your solution. So what will be the elevation in boiling point? That will be delta TB. Delta is always denoting the difference. Okay, fine class. Then what will happen in this case? It will be TB minus delta, TB naught, because TB is always going to be more than TB naught. Alright, now let's say for dilute solutions, you know, this is experimentally determined. Don't go into detail ki ye kahan se aaya. Alright, so for dilute solutions, this delta TB na means the elevation and boiling point is directly proportional to the molality, means the molar concentration of solute. So if I remove this proportionality sign, I get the proportionality constant Kb, which is very important. This is known as the boiling point elevation constant or the molar elevation constant. Okay, and its units are Kelvin kg per mole. You must know that. Alright students, so this is the elevation and boiling point. Now you know what is molality, right? Molality is the number of moles of solute dissolved per kg of the solvent. So if I am having W2 grams of solute, which is having a molar mass M2, alright, it is dissolved in W1 grams of solvent. So what is the molality in this case? Molality will be number of moles of solute, this one, divided by mass of solvent in kilograms. Okay, I have taken grams now, so I'll be dividing it by 1000. So it will come out to be 1000 into W2 upon M2 into W1. Now can you see students, now I'll be putting this value in this equation. So delta TB would be equal to KB into 1000 into W2 upon M2 into W1. So whenever this numerical comes, you directly have to take this formula. But you must know where this formula has come from. Okay, so I told you now you can calculate M2 from here. So you can calculate M2 from these colligative properties formulas. That's the speciality in this case. Delta TB will be experimentally determined if KB is known. So this is the final result that we are having. Alright. So this is how students' colligative properties behave. Alright, so we have discussed two colligative properties, relative lowering in vapor pressure, elevation in boiling point. Two are left, which is depression in freezing point and osmotic pressure, that I will be covering in the next session. So do remember what I have told you for today, that go through the questions. I'll again tell you at the end. Go the question number 2.1 to 2.7, the in-text questions of NCERT. And if you have any doubts, please post it in the comment box. I will be solving the questions for you. Okay? Because again, practice the numericals as much as possible. And see you in the next class. Until then, thank you so much. Bye-bye.